This is chapter 9, puppeting on strings. So we will talk about strings here. We have seen about the arrays and how array work, what are the size and dimensions, how to pass arrays to a function. And with this knowledge of arrays, now we are ready to handle these strings, because strings are nothing but arrays. These are character arrays. Strings are character arrays, and we'll also know how the pointer is going to help us to handle the strings or character array. So what are strings? Strings, as we just saw, the integers can be grouped in integer array. Similarly, we can have characters. We can have characters inside an array. These are characters like a, x, /n. All these are characters. And these characters inside an array is called as the string. In many languages, you will see that these strings are actually treated as character arrays only, but they are somehow concealed from us, from programmers. We are encountering always word and sentences in our programs. For that, we know that we are going to deal with these strings. A string constant is nothing but a one-dimensional array of characters which is terminated by /0. In C, the string or character array is always terminated by a /0. So if you say, I have a character array and this is a character array, the end has to be /0 if you want to make it as a string. So /0 is very important. So what is /0? If you see this /0, every time you say /n/t, these are escape sequence. So this is not equivalent to 0. We have a slash here. Since this slash is there, this is a special character, and the ASCII value of /0 is nothing but 0. That is, the ASCII value of 0 is 48, but this ASCII value of /0 is 0. Actual value of /0 is 0, but it is not 0. So every time we deal with a character array, we see that these are the characters and we terminate it by /0, which is actually showing or indicating the compiler that we have reached to the end of this character array or this string. This is very important. You have to put it by yourself in C. The string which is not terminated by /0, if you don't put it, it will not be a string. It will be merely only the collection of characters. So C actually concedes or conceal this from us. How? If we initialize a character array like this, you just have to write this. How it is concealing? Because there is always a /0 which a C puts here. This is not necessary here, but C will automatically insert a /0 here. So /0 becomes very important. Now, the question arises, how we are going to deal with this string? We'll see some programs. This is a character array and this is double quotes. Inside this you have a series of characters, and this has become already a string. A /0 is added here by C. So how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8. So we start with 0, int I equal to 0. We go up to 7 and we print all the characters of this array, character array, which is the string, and we say I plus. So this Pressman will be printed. This is a while loop. Now there is no necessity that you always put a number, because for this 7 you ought to know the numbers, because I computed this before I went inside this program. Is there any possibility that we don't compute the numbers? Because it will be very difficult. Every time you have to compute it. If you are aware, then it is okay. But you don't want to compute. You don't want to find out how many characters are there. So this program can be rearranged or reconfigured in this way. We start with I equal to 0, and we know that the end we have /0. We know that the end of Pressman is /0. So we go up to not equal to /0. So all the characters are compared with /0. If this is not /0, that is, we have not reached to the end of the character array, we print the character, that is name I, and we increment. So here also we'll get Pressman, because the length of this string we rarely use. We don't know it actually. Now, the same program can be written with the help of pointer. This is an array, so we can directly use the array with the pointer. Always we know that the name of the array is pointing to the first element of the array. The address, this is the address. Name is the address of the first element. So we make a character pointer and we assign this name, because this is an address. We can directly assign name to PTR. So this PTR address will have the address of name now. Now the value at this PTR, whenever or till the time it is not equal to /0, we print the value at that pointer and we increase the pointer. This is how it is done. So this is the similar way of printing. This is the value at pointer, this is the address. So this PTR can be incremented, it goes to the next location till /0 is encountered. The character array, because character is internally treated as integer only because the character shows inside the ASCII value. Computer programming doesn't know A, it knows only 65 number, which is the ASCII equivalent of A. So we deal with character the similar way we deal with integer. So name I star name plus I star I plus name I name, those we learned in integer array directly applies to character array also. See, we have taken one by one character or character array. In printf, we had a very good idea, but we have the format specifier as %c. Now your question should be, can I write this, or can I put or print this string at once without using loop, without using any while or for? Yes. The answer is yes. You can use %s. %s is the format specifier which will show this string at once. But here is a catch. The catch is this %s, which is the format specifier in printf. It can be directly used, enter a name, take it in %f, you can use it in scanf also, and just print this %s name. So this character array, you have taken the name and printed it. But the catch is if, see, I have given name as Debashish. It perfectly ran and this showed us Debashish. No problem with that. But the declaration will set 25 bytes, goes up to /0. /0 is never computed. Only 25 bytes of character will be computed. That is why all the values will be stored at proper location by scanf. But scanf, as I just said, there is a catch. Before that, the length of the string should not exceed the dimension of the character array. This is your responsibility to check the bound. If you exceed the bound, you will get some irrelevant result. Scanf is not capable of receiving multi-word string. This is the catch, because if you say Devashish, you place or you have a blank here, then you give Roy, only Devashish will be taken, this will be discarded, right? So how to get Devashish Roy completely in scanf? You cannot use %s because it will take only Devashish. Once any white space is encountered, it will ignore it. After that, for that you use getS. Now you put a printf, enter name in the character array and getS, get string, and you will take this name. Then you put as hello, then you put as name. So now this name, complete Devashish Roy, will be taken and this will be shown. So this was the thing. This puts and getS. GetS gets the string. This can take multi-line also. Multi-word, multi-line, no. Multi-word. Then there is one more way. If you want to really use scanf, you say I don't want to use puts and getS. I don't want to use getS. I want to use scanf only. For that you have to write this. This will be format specifier %square bracket, then this cap /n and it s. This you have to write, and this will be very difficult to write. So better use the getS. Pointers and strings. Now you want to store hello. We can store it in certain way. First is you say character string and you give an array and put like hello. But you can also give the address. You are saying character *p means this is the address, this is the pointer, and you have assigned it to hello. So now this hello, wherever it is put, the P is going to point to the first location, that is H. I hope you got the idea. So there is a difference between these two. We cannot assign string to another. We cannot say str1 is equal to str2. This is illegal in C. But when you are dealing with pointer the way I showed you, you can easily do it. Say you have str1 as hello, str2 you have not initialized, but you say we have character pointer s as good morning, a character *q. If you assign str1 to str2, this is going to give you error. But when you assign s to q, because these two are pointers, this is going to work. Because what you are doing here is, you are just changing the addresses. You are just saying, okay, I have this address, now you take this address. When you are dealing with character pointers, once a string has been initialized with character array, it cannot be initialized otherwise, or it cannot be initialized to another set of characters. For example, you have string 1 which is initialized as hello. Now you have str1, you want to initialize with some other word. This is not possible when you have a character array. But if you initialize this with a pointer, now you want to initialize anything to the by, to the p, this is going to work. Standard library string function. So we have various functions which are provided by the string equivalent of, or you can say standard library functions are there with us. String length to find the length, str, lwr to convert a string to lowercase. To uppercase you use str upr. This is for concatenation, adding of those two string. strn, wherever this n is there, you just understand that we are appending, or you are doing with the first n character of the string. So this is appending the first n character of a string at the end of the another. strcopy is copying string into another. strncpy is copying first n string of one string into another. This is compare. So you compare two string. strn compare cmp compares first n character of two string. strcmpi, strcmp, strnicmp all are same, but in this one it compares two string without regard of the case, I means ignore. stricmp, it compares two string without regard to case, identical to this one. strnicmp, where n has come, so it compares the first n character of two string without regard of the case. strdup, duplicating a string. strchr, finding the first occurrence of a given character in a string. strrchr, finding the last occurrence of a given character in a string. strstr, it finds first occurrence of a given string in another string. strset, setting all characters of a string to a given character. strnset, setting first n character of a string to a given character. And strrev, that is, it reverses the string. These are all the different functions which are available, which we are going to use directly. strlen, strcpy, strcat, strcmp, length, finding length, copying it, concatenating two string and comparing two string. These are used widely. strlen, this is for finding out the length, or this function counts the number of characters which are there in the string. Let us see a program. You have a character array, you have length 1, length 2. You want to find out the strlen, arr, you just pass, or you pass any string, it will give you the length. You just print the %d, you will get length as 10 and 30. So this strlen, we are passing the base address of the string in the first one. So it is returning the length of the string. In the second one also it is calculating the length. Okay, can we write one more function which can imitate the standard library function like strlen? This can be written. Let us say that we are writing it. We have same program, but we have now not strlen but xstrlen, and we are saying we are going to write the code of this by ourselves, which will be equivalent to the standard library function strlen. Let us see. This is the function. We are passing the string or the address of the string. Then we are saying length equal to 0. We go up to /0. We'll increase the length and we increase each character of we go up to the /0. And incrementing 111 character, and we return the length. So this is doing exactly what strlen should do. We again get the same result. So this function is quite simple. It is counting the character till the end of the string which is not being meant, which is /0. And second, this is the length. Second is just incrementing the next character, means going to next character. strcpy, string copy. This will copy the content of one string into another. So we have source and target. See here, we have a source sayonara, we have a target. We have not initialized it. We are saying strcpy, the source content will be copied to the target. If you print now source and target, both are going to show you sayonara. Now we are just supplying the base address and we are copying it from the first values character by character. So the second value, second dimension has to be such that the first or the source can be copied to target. It has to be large enough. So can we have a function? Can we write a xstrcopy which mimic or which imitate strcpy? Let us give it a try. Yes, we are now writing xstrcopy, which is quite equivalent to the same copying the source to target. This is our function. We are passing the source and target. This is source, this is target. Until the source goes to /0, what we are doing here, we are taking a single value, transferring into t, incrementing both. Means taking one value, transferring it here, going to second value, transferring it here. So essentially we are copying, and when we went to this target, and we have to put by ourselves this /0 to mark the end of the target. So this is again sayonara. So we are doing what? We are saying one-to-one copy. But if you go to strcpy, you will see, if you go to actual function of library function, you will see that this will not be character start. There will be constant also. Why this constant? This constant is because sometimes the source can be changed like this. Any problem can be there. Means the user or programmer or by any means the value of a source can be modified, which we don't want. And when we don't want anything to be changed, we put a constant here. So now this accidentally change needs to be avoided. For that, we'll make certain changes to xstrcopy. We'll put a constant here, and then the things remains the same. Now accidentally, even if somebody wants to change source, it will not happen. Now this declaring of char star as constant, we have made it as constant. We can use constant in several situations where it can be used. Now let us see how to use this constant in various scenarios. See, we have character pointer here, hello. This pointer is a variable, so it is a string basic. We assign m to p, it will be assigned a character, single character. If we assign the string or character of array or string to p, the address, it is going to work. But here, if we say constant and we have simple, this same thing is there, but we have just constant here. So when we want to assign the value at q, that is, this cannot be changed. The values cannot be changed. If you just want to assign m to the star q, this value at q, there will be error. But now you can assign q, this address to by address to q. There is no problem. Now again, now we are shifting this constant inside this. We are saying char const star s. That means we have a string which is fixed pointer. String is fixed pointer, which is not. So what we are saying here is, this is string is fixed pointer is not, and this is string is fixed pointer is not. That means that when you have a constant here and when you want to assign some value to any point here, it is going to give you error. And again, as the similar way it is going to work, you can assign the address or you can assign the address of b to s. Now we are saying this, let us take star here. So this is character star constant t. Now this constant t, when you say constant t, so now this t cannot be changed. So when you assign t with by any string, it is going to give you error. But now this star t, value at tm can be given. This work. When we have const char star and now we have const u. Now this is also constant. This is also constant. Neither you can assign the value at u as any value, or neither you can give the address as by. These all becomes invalid because you have both const. So this const can be used as we used it with int float. For example, this is pi 3.14. We said this is constant. Pi will never change. String cat. String cat is simply taking two strings, adding them together without a blank, right? The folks hello, you say string cat source target. The source, this target will be added to the end of the this target. Means source, this source and this target. So source string is folks and then target string is hello folks. Can we write a function like xstrcat? Let us make it, and I hope you will be able to make it. We come to strcmp. Strcmp is string compare. Now this is very important, because here we have comparing going inside, which is in terms of ASCII. So if how to compare, say I have word as hello and I have word as hell. So when I compare, H will match with H because both have same ASCII value. E will match with E, L will match with L, L will match with L, but O is not going to match with /n. So the difference of the ASCII value of 0 and ASCII value of /n will be returned. This you will see in a program. We have string Jerry, we have string second as Jerry. Ferry. When you compare string 1 with Jerry, because string 1 is actually Jerry, you will get this as 0. You see here. You will get 0. When you compare string 1 with string 2, Jerry and Ferry, because J and F, they are different. So the difference of the ASCII value will be given, which is 4. How about this string 1 with Jerry boy? You see, string 1 goes to Jerry. This is okay Jerry. But here you have last /n. Here you have blank, which is the space. So /n and 0, this blank, the difference between these two ASCII value will be shown, which is minus. I hope you got the idea. Minus 32 has came because we are subtracting the ASCII value of /0, which is 0, with the space, which is giving two-dimensional array of characters. The way we have seen about the two-dimensional integer array, we will deal with the characters in the same way. And first we will start with an example. Here the program is going to ask for your name, and then it will check the name in the master list, and that master list we are going to make it as two-dimensional array of characters. Let us see how we can make a character array, or you can say two-dimensional array of characters. So this is a character array which is two-dimensional. This is first dimension, this is second dimension. First dimension is the number of rows, or number of rows are here. So how many rows are there? 6. 1, 2, 3, 4, 5 and 6. These are 6 rows. And how many columns? The columns are fixed here. These are 10. That means if I can show you one row, this will be something like this. We have 10 blocks here. Assume that these are 10. So we start with A and we write and we end with somewhere, say here, /0. And this is, say, Y, Akshay. This is how it will be stored. So let us input your name in your name and we set a flag, not found. And then we start with the rows, first row, and then we compare the first row name with your name, what you have entered. If it matches, if string compare returns 0, then we change the flag to found and we say, okay, very good. The name is being found, you are allowed or whatever, and we break. If we don't enter this block, then the flag will always be not found because we have initialized it with not found. So we say, okay, you are a trespass. So this is the result. Now this two-dimensional array we have initialized and you have seen the order of subscript. The first subscript gives the number of names in the array. The second subscript gives the length of each item in the array. And rather than initializing the name, we can also supply the name through keyboard. How? See. From 0 to 5, because these are 6 values, ampersand we are scanning up in %s and saying master list I0. I means all the number of rows and this is pointing to the first location. And this string compare, as you saw, when we compare the name which are coming with the master list, if it matches, it is good. We say, okay, your name is successful, you can enter whatever. And then if it doesn't come A as 0, then we say no. This flag shows, or this will print, or this flag we have used for showing whether the name was found or not found. Each name is ended with or ends with /0. If you see the proper scenario, how these two-dimensional which we have initialized is seen, is we start with A, we end with /0. Again we start with P/0, and this is how. One thing needs to be observed here, that we have assigned 10 bytes. This was 6 and this was 10. So this 10 bytes is assigned for each and every name, whether it is 10 characters or not. Unlike, means we are saying that 10 bytes are assigned. See 54 is there, next comes at 54, then next comes at 64, then 74. So there is a difference of 10 bytes. But here 3 bytes are wasted. Here 4 bytes are wasted. 4 bytes, 1 byte, this 4 bytes, 3 bytes. So this, because we have given 10 bytes, for the first name we say 7 bytes are only occupied along with your /0, the ending, you can say a character. 3 bytes are wasted. So can we have a way how to avoid this wastage? Yes, we have. We will look at array of pointers. Array of pointers to strings. If we just make an array, say I'm making an array master list and I'm saying I'm giving it 6 rows and 10 columns. So the name, even if you enter less than 10 bytes or 10 characters, it will take 10 bytes only. Each name, say 6 names are there. All names, the names can be smaller, the names can be of the order of 10 characters, but which are smaller is going to give you some spaces which are wasted. So the pointer variable always contain an address, we know that. So if we construct an array of pointer, it would contain number of addresses. Let us see in this way how the names in the example as I just told you can be stored in array of pointers. So these are, if we would have placed it in the way I showed you, it would have been char, name, 6 and then 10. But here we have initialized an array of pointers. Now these are 6 names and then the name is the array of pointers. So it is containing the addresses. So name 0 is pointing to Akshay, name 1 will be to Parag and so on. So this is how. Now this array of pointer is containing the address of 182 and 182 address Akshay is stored. Again, when we go to this 65516, this is an array which is having the address. This is array of pointers, and this 189 is pointing to Parag. I hope you got the idea. This is not containing any name. These are containing the address of the name. In this, if we take 6 and 10, two-dimensional, so 6 into 10, that is going to take you 60 bytes. But in this case, if you just count these numbers, if you just count the names, this 1, 2, 3, 4, 5, 6, 7 for /0. All this if you count, you will see that only 41 bytes will be used. So you are saving 19 bytes. 19 bytes. You have 19 bytes, but there is one more catch, that for this storing of addresses, you have consumed 12 bytes. So in all, you have saved only 7 bytes. So what is the reason to store string in array of pointers? First of all, you are using efficient use of available memory, as I just told you. But there are other reasons of. We have a greater ease in manipulating the string. And the first one, we'll see some example. First is going to use a 2D array of pointers to store the name. The second uses the array of pointers to the string. First, for 2-dimension array of characters as this one, and second will have array of pointer. And though both programs are doing the same way, we are trying to exchange the position of the Raman and Srinivas. position in the array. See, this is exchanging the name using 2D array of character. So this is 2D array of character. You can give dimension here or you cannot give. It will automatically take. Here we have original. If you print this names 20, this is 0, this is 1, this is 2. 20 will be Raman and names 30. This is 0, 1, 2, 3, 4, 5. This will be Srinivas. Okay, this will show you because percentage is there. This will show you this Raman and this will show you Srinivas. But our intention is to exchange the places. Raman goes here, Srinivas goes here. For that, what we do? We start with 0 to 9 and every point we take a temporary variable and transfer the content, means character, from one point to another. Means R is exchanged with S, S is exchanged with R, A is exchanged to R, R is exchanged to A, and likewise. Final result will be the exchange of name. You will see Raman Srinivas and Srinivas Raman at 2. Previously it was Raman, now at 2 it will be Srinivas, so they will be exchanged. So this the exchanging, we are actually transferring or exchanging the proper characters. We are taking one character by one character and exchanging. So 10 exchanges are needed to interchange two names here in this case. But we will see an example where we don't require that much of effort. We'll use the array of pointers to string. This is array of pointer to string. We take a temporary character array. Now this is original, means name 2. This is name 0. This is name 1, like this. So we are saying name 2. That means this 2 will be printed and this 3 will be printed. 2 and 3 will be printed. Now what we're trying to do here is, because these are addresses, we are just saying that we have this 2, 3. This is T. First we will transfer 2 to T, then 3 to 2, and then T to 3. This is all going on. So when we print this, Raman will be Srinivas, Srinivas will be Raman. We have just changed the addresses or pointers. As you see here, again we'll get the same result, that is exchange. And this program, the only thing which we required was to exchange the addresses, nothing else. We are not taking character by character exchange. So this will make the handling of strings very convenient. And when we talk about the efficiency in memory usage or ease of programming, this array of pointer to string will score better than the 2D character array. This is the reason that even though this principal strings can be stored and handled through a 2D array of characters, it's quite easy to handle. But in actual practice, the array of pointers to string is commonly used. What are the limitations of array of pointers to string? As we said that 2D, the array of pointers scores better than 2D array of characters. But when we are using the 2D array of characters, we have a liberty. We have a freedom to either initialize the strings where we are declaring, or we can receive the string using scanf in 2D. But in the case of array of pointers, we can initialize strings at the place where we are declaring, but we cannot receive it through keyboard using scanf. Let us see a program. We have array of, say this is array of pointers, and we say 0 to 5, enter name, and we want to enter the name. This program is not going to work, because when we are declaring the array, it will contain the garbage value, because we are not initialized, and rather we are sending actually the wrong values to this scanf. So it is going to give you the garbage value in the print. What is the solution of this problem? If you want to receive, if you are eager to get the content through keyboard using scanf only, what you can do here is, we'll change the program somewhat. We'll use alloc.h. This is the name character pointer, or you can say array of character pointers. Now this is a temporary variable we have used, temporary array, temporary variables and character. Here we have said, okay, enter the name. Every time this n, we have a character array. We'll take this name in %s. We'll find the string length of this, whatever is entered. This length we take. We use malloc. This is memory allocation. We are dynamically allocating the memory to length one size, and now we are copying the content of n to p, and then we assign this p to name I. This is possible. This you can do, and then you can just print. So we have received a name scanf. We have found out the string length and allocated it to malloc. Then we converted this to char star, because the return by the malloc is void star. Malloc always return this void pointer, so you have to convert it into some character float integer, and then this malloc has come from alloc.h, that has to be included. So why did we not use array to allocate memory? Because when we use an array, we are committed to the size, that the size has to be given, and there is no way in later part we can increase or decrease the size, because it is an array. So we are using actually static memory allocation. But while we are using malloc, we are using the dynamic memory allocation. We pass the argument to malloc, and it will assign that size in the heap. That is dynamic memory allocation. So once we have allocated the memory with malloc, we have copied the name received through the keyboard into the allocated space, and then we have finally stored the address of the allocated chunk to the appropriate name. First we allocated the name, then that chunk has been allocated to the name. That is the array of pointer to. So this has some performance issue because this allocation of memory takes some time, and this is taking the memory, copying it to the string. So it has some performance issues. So let us summarize what we have seen in this chapter. The string is nothing but an array of character which is terminated by /0. This is null character. The ASCII value is 0. And because it is an array, all the characters are stored in the continuous, contiguous, or you can say one by one memory location. Scanf can be used to receive multi-word string. GetS can do the same job in a cleaner way. This printf and putS, they are able to handle multi-word string, means the words which are separated by some blank. String can be operated using, we have various standard library functions. Few of them are and mostly used as string length, string copy, string cat, string compare. We can manipulate the string. You can also write your functions. The principle of 2D array, this can be easily used to handle strings, but in practice the array of pointers to string is preferred because it is going to take you less space and efficient processing string. Malloc function can be used to allocate space in memory on the fly during execution of the program. So this is all about this string chapter. Thank you so much and take care.